reactions that take place inside our cells in order to sustain life. When these chemical reactions happen, they leave behind traces, almost like fingerprints. We call these fingerprints metabolites. One of the premier institutions for studying metabolites and their importance to human health is the prestigious North Carolina Research Campus Human Performance Laboratory. And so, ASEA contacted Dr. David C. Nieman, director of the Human Performance Laboratory at Appalachian State University. Dr. Nieman, the vice president of the American College of Sports Medicine, is the author of 9 books dealing with physiology and exercise testing, more than 200 peer-reviewed publications, and more than 300 articles in health and wellness magazines.
We have a national reputation for testing various sports nutrition products and their effect on performance and exercise-induced physiologic stress. So this campus, the North Carolina Research Campus, we have several universities that are here, including Duke, UNC Chapel Hill, NC State University, and we're working together with various companies, Dole Foods, General Mills, and we're all working here together really under one mission, which is the connection between nutrition and health and performance.
The North Carolina Research Campus was established to bring together researchers from a variety of different universities, from a variety of different companies, all sort of focused on health and nutrition and agriculture-based research. So in that sense, it's a very unique structure.
The reality is we wanted the best, and everyone we talked to a person said, if you want the best, go with Dr. Nieman, his team, and the North Carolina Research Institute, and that's what we did.
And so in late 2011, Dr. Nieman and several other PhDs carefully crafted a scientific study. A study designed to measure the effect of ASEA on metabolites, the fingerprints left behind as a result of cell metabolism.
So the way that we conducted the trial was to randomly assign half of the subjects to one treatment and half of the subjects to the other treatment. It's a double-blinded study, meaning that we as the investigators had no idea who we were assigning to what condition, an A condition and a B condition, but we didn't know what those were. So the subjects are assigned to either A or B. They come in and they do the first trial and they ride as hard as they possibly can, and then they cross over, meaning that if they were on condition A to start with, they would then transition to treatment B or condition B for the second trial, and vice versa, B to A. And so in that way, we're really testing, we're taking everything out of the equation as best we can by just leaving it to the athlete and the bike and riding as hard as they possibly can to test the possible benefit of ASEA.
We drew blood samples on the athletes after they had taken ASEA or placebo for a week. That was just before they cycled 75 kilometers, and then we took another blood sample after that, and then an hour later.
The rigorous protocols of the double-blinded crossover study took several weeks, and the analysis of the blood draws took even longer. Back in Salt Lake City, ASEA executives were anxious for news.
We knew that they were doing cycling trials in North Carolina, testing ASEA. And we waited for results. And we waited, and we waited, and we waited.
Then we heard from Dr. Nieman again. And he said, what we want to talk to you about is too important to talk about over the phone. We'd like you to come down here and meet with us here in North Carolina.
The ASEA corporate team immediately flew to North Carolina, where they learned that the results of the study surprised the entire group of PhDs. They were expecting to see something when ASEA was combined with exercise. Instead, they found chronic results. That is, results that happened before exercise, simply from drinking ASEA.
We didn't think that drinking ASEA would shift metabolites chronically. We thought it would do something during exercise, but not after a week of drinking it. After working with the bioinformatics statistical division, we were able to determine that drinking ASEA over 1 week caused a shift in 43 metabolites. Not a little shift, it was a large shift that caught us by surprise.
When a metabolite came back from ASEA, we were just like, wow, there's something really interesting going on that we weren't picking up from our traditional markers.
And the last data set that we had come in was metabolomics, and there were these huge differences in free fatty acid mobilization. And so that was kind of a shock to us because we weren't expecting to see anything at that point, but there's certainly something going on there, which is really interesting.
We have rarely seen such a drastic difference. In the compounds that we look at, we're looking at probably about 150 to 200 compounds. For 43 of those signals to change, that's a quarter of the metabolite profile that we're monitoring. So it's a huge bump in metabolite shifts due to just ingestion of one product. So it's a drastic difference.
I didn't believe it. So when I saw this, you know, that 43 metabolites were differentially, they were at different levels. I didn't believe it. And I've done studies with microarray analysis where you're looking at thousands and thousands of genes, and you might find 2 or 3 genes that are differentially expressed. But here we are in metabolomics, and you find 43 things that are different. It was astounding.
The data revealed shifts in 43 metabolites, something these PhDs had never seen before, something that caused these scientists to use words like astounding and massive. But what exactly did these metabolite shifts mean?
Many of the metabolites were related to plasma free fatty acids. So the athletes actually started the exercise after drinking ASEA with a lot more of these free fatty acids in their blood. The reason that's important is then the muscles will actually use that as fuel, sparing the muscle glycogen and the use of amino acids, which is what we found as we analyzed the data.
And the free fatty acids are very important because during exercise, we'll oxidize those to make energy in the form of ATP.
So what we found in this study was that there was increased fatty acids that were available. And fatty acids are a fuel source for exercise. So if they are available, then what could be happening is we might be able to go a little bit longer with ASEA. We might be able to recover quicker between bouts. So there's a lot of things that are coming out that are quite exciting.
My thoughts on the study is, well, my first off one was sort of like I already kind of knew this, just through my own experience with the product. So, but at the same time, it's great to have that solid evidence, that laboratory test that makes it official, gets the official stamp of approval from the scientists, and then to go along with the stamp of approval from